welcome to already the 10th episode on this GooseV2 build. This video is about the engine nacelles. I've been posting pictures on Facebook and the threads on RC-Groups and have gotten many questions on how I did the pre-cut strip planking. So in this video I will show you a bit of that when we look at the CAD design in Rhino. As you can see, the nacelles turned out very nice. I'm very happy with it. The nacelles are built up using laser cut plywood parts to form the framework, while the real treat are of course the pre-cut strip planks. I got this idea from the Grumman Albatross build from Ziek Brewbreaker from Park Scale Models. So I adapted the idea and used it for this Goose also. So let's take a look at the design and after that the build videos. Have fun! These are the plywood laser cut parts for the nacelle. I exploded them here so you can see the parts as separate items. They're all interlocking using depth locks, so it should go together very easy. Let me just reassemble it. So this is the nacelle framework. You build it as a sub-assembly before installing it in the wing. Let's make it spin and look at it before moving to how the nacelle was inserted in the wing. So this is the wing, and we need to make a cutout in the wing. Then insert the nacelle frame with glue obviously, and it's then locked into place with one of the wing tubes. So then the pre-cut nacelle planks. Many of you have been asking how I made the pre-cut nacelle planks for the Goose. So I want to show you some CAD work I did. You see here is the basic 3D model for the GooseV2. This is the model I used to make all the laser cut parts. And for now let's zoom in on the engine nacelle. If I select it, it's clearly visible that this is a complex shape with compound curves, so it's impossible to make accurate flat surfaces out of it. To be able to do that, the nacelle surface has to be modified into something looking like this. This is a simplified shape of an engine nacelle, and it's also divided into the top and bottom, which makes it easier eventually to glue the sheets in place. The forward part of the nacelle is a cylinder shape. This is a single curve shape which can be unrolled. For the area behind that, the original 3D model, it's a compound curve shape, so you cannot unroll it. But I simplified it into single curve planks which can be unrolled. These planks were made using these rails and cross sections I made. The blue curve here is the original round curve, and I made new cross sections. These are the green ones, and these are straight. For now let's just delete the round one. I will show you how one single strip plank is made. So you use the command sweep to rails, then select the rails and the cross sections, and there you go. This is an individual or plank which can be unrolled. So how does this unrolling go? You select the surface you want to unroll, use the command unroll surfaces. We do not want to explode it, and yes, I want labels, and you press enter, and there it is, the unrolled cylinder part of the nacelle. These are the same two parts. We can do this also with the strip planks. And they're all laying on the construction plane, the unrolled surfaces with labels, so you can orient them in the correct way. So after a few minutes you will have all the individual parts, which can then be put back together as you like. And then one thing that you will notice is that the dimensions of the unrolled cylinder part do not match the planks, because obviously I simplified the shape. You see here that there's a little difference. This is easy to solve using the command transform, scale in a single dimension. You choose the base point here, and then the first reference point by the end of the start of the nacelle plank, and then you just scale it to the end of the cylinder part. So this is an unrolled plank surface, and you can make, I did make these single parts of it, so they fit on the laser cut parts. So I hope this makes it a bit more clear on how I made the pre-cut planks, and it will give you some insight.